Hi, I apologize, I know the lighting is awful. I just wanted to do a quick follow-up, and I talked to my friend who owns this Kahr CW45, mentioned in the other video, and I will put the link up in the corner, no, actually that corner, to the original video, which you need to watch for this one to make any sense. And I've disassembled the frame, and I've started to push out the trigger pin, which you can see right there. Got my short little punch, which makes it easier, and you push the pin from the left side of the pistol to the right. It has a little flared end on it, so it won't go the other way without destroying your frame. That should be obvious, but it's amazing the obvious things people overlook when they're frustrated and in a hurry, so maybe I'll save somebody some trouble if this comes up. There's a little spring in here which wants to go flying, I'm sure. Anybody who's done any gunsmithing or anything like that will be familiar with the joy of hunting for springs. So if you're doing this, it's really nice to do it in a clean area that doesn't have any nooks and crannies or carpeting. I don't have an area like that, so I'm going to do it in a place where springs like to hide. Anyway, I will stop this and show the next step. Just one little thing. Here is the little, I'll call it a ferrule, and the spring that reset the trigger. The ferrule's secondary purpose, or actually probably primary purpose, is to hold the trigger bar's lug engaged with the little hole in the top of the trigger. So obviously you want to pay attention to which way this is oriented. The flat spot on the ferrule is oriented forward against the flat machined surface on the inside of the trigger, and the spring crosses at the front, not the back of the gun, with the little bent end downward. The easiest way I've figured out to get this in is to hold the thing in a vise. I don't have the proper vise, this is what I use. Pretty pathetic, I know. But anyway, anything that holds stability. I've got the pin engaged in one side of the trigger and a punch of the same diameter opposite it, but not actually sticking into the central area of the trigger, the channel. And that enables me to push it in from above and behind with pliers until I can shove one or the other of the pins in enough to get it engaged. That is the most difficult part of this whole process. Back in a second. Hi. Okay, so I've just dropped the trigger out. The spring actually wasn't too likely to go flying, so that's a nice thing to know. The spring, a little ferrule that holds the spring around the access pin, and the trigger drop out downward through the trigger guard. Just hold your finger on it while you pull out the pin the rest of the way with pliers, and you shouldn't have any trouble. You kind of have to rotate the trigger forward to let it drop free. Fiddle with it and it will make sense. So I wanted to show you the trigger and get as good a picture as I can of the area where I'm going to remove material, and I'm talking about removing very small amounts of material. So if you can see, here's the trigger. You're looking at it from the right side of the gun's perspective, and you'll see from the left side that it has a smaller radius on the left side and a raised radius on the front side, with the area that I was calling the spur earlier, which is this corner right there where I'm pointing with the probe. Actually, this is a torque screwdriver, but you get what I'm saying. And here I've highlighted it in red in the area where I intend to remove material. Can you see that? There's red. If you look on the side, let's see if I can get it to focus on there. There's just a little bit of red right at the front. That's the area where I'm going to remove material. If you look at the piece when you have it out, there's actually a little flat spot where it contacts with the frame, so it isn't a sharp corner digging into plastic. So that at least was partially thought through. I still think it would be better to have controlled that travel with a part traveling in a linear motion, such as the trigger bar, rather than the trigger itself. But it works. Well, usually. It obviously doesn't work right now. A friend who is very knowledgeable about firearms made the point that usually when you see deformities like this, It's when they're rushing production and not letting the molds cool enough in between cycles. You could call it the Kel-Tec formula for success. Anyway, pretty much anybody who makes a plastic gun has had a batch here and there where they've had this kind of problem. Same for plastic magazines. And this gun was probably made during the rush for the gun buying panic of late 2012, early 2013. Anyway, so what I'm going to do is remove a minuscule amount of material from there, put it back together and test it, and if I need a little more travel than that, I'll keep on going till I get the right amount. I'll pause the video and show you what it looks like when I'm done. A good practice point if you're doing something like this is to put marker on the area that you're removing material. Take a swipe on, I like a diamond knife sharpener because you get very consistent material removal on a very flat surface, which gives you a good feel. Files are kind of too aggressive and natural stones can wear unevenly. Anyway, I've got diamond ceramic stones too, in varying degrees of fineness that are as nice as any gunsmith tool, I guarantee you. Cheap diamond stones suck. You want EzeLap brand. Anyway, put marker on the place you want material removed. If you're holding it square, you'll see that material come across square. And it gives you a good visual guide to how much you're taking away. We're going for a small, like 2 or 3 swipes on a medium coarse stone, test and fit, and try it again until we get the right amount. It's a whole lot easier to remove material than to put it back, and this actually came apart pretty easily. I expect to go back together pretty easily. See you when I have it done. Just one little thing. Here is the little, I'll call it a ferrule, and the spring that reset the trigger. The ferrule's secondary purpose, or actually probably primary purpose, is to hold the trigger bar's lug engaged with the little hole in the top of the trigger. So obviously you want to pay attention to which way this is oriented. The flat spot on the ferrule is oriented forward against the flat machined surface on the inside of the trigger, and the spring crosses at the front, not the back of the gun, with the little bent end downward. The easiest way I've figured out to get this in is to hold the thing in a vise. I don't have the proper vise, this is what I use. Pretty pathetic, I know. But anyway, anything that holds stability. I've got the pin engaged in one side of the trigger and a punch of the same diameter opposite it, but not actually sticking into the central area of the trigger, the channel. And that enables me to push it in from above and behind with pliers until I can shove one or the other of the pins in enough to get it engaged. That is the most difficult part of this whole process. Back in a second. Okay, well, I have just finished fitting the trigger. It took 3 or possibly 4 fit check cycles to get it, the trigger to the right amount of overtravel, or what I deem to be the right amount. Your mileage may vary. So what I ended up with was moving it from 0 overtravel, or possibly a negative 1/28th overtravel at room temperature, to at room temperature having approximately 3/64ths overtravel, which seems to be about right. I've chucked it in the freezer right now, and I'm going to see that that still works with a little bit of fudge room, even when it's down at freezing level, and if it is, I'll call it done. And if that's the case, I don't really feel like pulling out the trigger again. But I wanted to show people how to get precise and square fitting of parts. So this is the sort of skill you would use when doing a trigger job. I've got just a little scrap of aluminum because I don't want to pull the trigger out, and this would be better with a proper vise rather than my carpenter's clamp, but the principle's the same. So what I'm doing here, I've got my piece of material that I want to cut square, and it's not square, and I want to remove a very small amount of material very uniformly and in a controlled way. Well, one good way to do that is cover it with Sharpie And if you sort of overhang the Sharpie on the side and press a little, it will leave a little bit, the marker will deform around the edge, and we'll leave it pretty uniform overhang mark all the way across. I'm not calling this machinist precise, but it gives you a very good visual cue to say 1/1000th of material. And so you can simply remove material till that mark is gone. Now, if we were just freehanding it, that's still sloppy and easy to make a quick mistake. So what do we do to control that? Well, we run the part down in our vise until it is flush with the jaws, and then bring it up until 1/1000th of material is exposed, squaring with it. And now guess what? We've got a good visual cue to get it lined up, and you can put a caliper or gauge on that to get it closer. In this case, we're actually doing a guess and fit, and even if it was round and not perfectly square, it would still perform the desired function. But, you know, anything worth doing is worth taking a little bit of trouble to do it well. So here I've flushed it up. Like I said, I'm working as a kitchen table gunsmith with not the ideal tools. But here, I've run it into a clamp with just 1/1000th or so, or actually it looks like about 2/1000ths, sticking up past the clamp. You can tighten that down good and solid, and take my EzeLap diamond stone, which is very uniform, very flat, and very predictable. Run that on my clamp back and forth until it's flush. I can keep my surfaces square or whatever angle I'm trying to preserve, like if you were doing a trigger job. This isn't really a trigger job in the sense of modifying an engagement surface, but the principle is the same. If you look at a professional machinist who does gunsmithing, they will do much the same thing, although often they will have gauges that hold their individual parts at a predetermined angle and amount of engagement depth to save them the trouble of trying to custom find their angle every time. And you just simply flush up your tool and run it until it is in contact with your vise jaws. And you can see, if you ink it up, if you're wearing irregularly. I deliberately put in a crooked piece. I don't know if that shows up, but you can see the wear where I took off the ink is uneven. Now, because my part is uneven, that's actually showing that it's level, but that demonstrates a good visual clue to tell if you're holding your tool crooked. And the smaller amount you have sticking up, the less misalignment you can allow. So this is a good way, if you're an average home user, to get precision as good as a CNC machine is going to do, and often better. Town I used to live in was home to McIlvaney Machine Works, which made, from what I'm told, the most precise mills and lathes of the World War II era. They assembled all of those by fast machining, but when they finished them up, they put on machinist bluing and sanded the control surfaces by hand and did hand lapping to do their final fit. The most precise machining in the world, 70 years ago-ish, was done essentially by hand. And my point there is not that we need that level of precision to make this work, but that as a home user, don't swear off a job just because you don't have access to a lathe or a mill. You can replace that with time, gauges, vices, and just being careful. If you have a good way to measure it and a good way to mark it and a good way to hold your tools steady, you can get very high degrees of precision. Just be patient. Anyway, I will pause the video again and come back when I have got the part out of the freezer. Okay, so I just took it out of the freezer. It's been in there for roughly an hour, and I tried a couple trigger pulls. I haven't measured this or anything yet, but it works, and it works easily. So you'll see there, got empty chamber except for a what do you call it, earplug in there, just as a chamber flag. I don't know if you can see, but whatever. I don't really care. And I'll pull this as gradually as possible, break, and a little bit further. Very small amount of overtravel, but it was enough to function, and I wasn't fighting the trigger. I'll try to do it vertically so I can get a better view. Yeah, I would say there's less than a 64th of overtravel here frozen, but that was a 64th of plastic that we used to be compressing, and we're now not compressing. That's good enough for me. I'm going to call this one done. I don't know, to me it reaffirms the thing that you never just trust anything because the brand is good. You check every example if it's something that's a piece of safety equipment. Anyway, so that went from a gun that would have been very difficult to shoot, if not impossible, to one that is just not easy to shoot quickly. You shouldn't have seen any sights dipping. Hopefully when I post this up and watch it, I'm not going to look at there and say a flinch. But what you would have seen before would be pull, strain, jiggle, snap. So much better. Anyway, that will be part 2. And for any of you who watched this video and didn't see the first one, there will be a link there to the first video.